Bom, pessoal, então a gente vai começando aqui. Vou fazer uma breve apresentação, em 10 minutinhos, até que a gente comece com o Dr. Roman, né? Bom, esse é o nosso terceiro encontro da curadoria. A gente fez uma primeira conversa em cima de riscos, oportunidades, né, ameaças e questões de mercado sobre inteligência artificial. Foi uma conversa que está bem conectada com essa conversa que a gente vai ter hoje, que é o desenvolvimento seguro de inteligência artificial, né? Já no sábado passado, quando a gente fez uma atividade mais prática, daí a gente desconectou um pouco desse mundo conceitual, dessa análise, né, de qual é o futuro, e a gente se focou no que existe de ferramenta hoje para a gente desenvolver. Então a gente deixou de lado um pouco as discussões comportamentais, um pouco essa questão de certo e errado, e fomos conversar sobre questões técnicas, né? Hoje a gente vai retomar a discussão em cima do desenvolvimento ético. E essa discussão ela é importante por quê? Porque a inteligência artificial, como qualquer outra tecnologia, ela pode ser usada para o bem ou para o mal. Mas por que existe uma preocupação? Pode mudar o slide aí, Rafa. Por que existe uma preocupação tão grande com relação à inteligência artificial? Porque o poder, né? A gente pode deixar aceso que fica melhor. Aqui? Não. Azul. Aí. Deixa aceso. Porque só um fundo aqui é bom que fica melhor a imagem. O poder de destruição, né, de uma ferramenta maligna, maléfica de IA é muito grande. Todos vocês viram aquele vídeo dos drones assassinos? Não viram? Depois eu vou soltar lá no grupo lá o link. Aquele vídeo dos drones assassinos não é uma realidade. Aquele vídeo foi feito pelo Institute for Life como uma iniciativa para mostrar o quanto que a inteligência artificial pode ser perigosa. Então ali foi uma demonstração combinando drone com câmeras, visão computacional para reconhecer rostos, capazes inclusive de reconhecer rostos individualmente, né, com capacidade então de se aproximar dessas pessoas e explodir, né, na testa das pessoas, fazendo uma perfuração de entre 5 e 10 centímetros no crânio dessa pessoa e matando instantaneamente. Então, aquele vídeo lá não está mostrando nenhuma tecnologia que a gente não tenha à nossa disposição. É uma realidade que já está aí. E se com o que a gente já tem já dá para fazer coisa tão perigosa, né, imagina com o que está por vir, como a gente vai conversar daqui a pouquinho. Por outro lado, né, o lado verde da foto é o seguinte: o tanto de possibilidade benéfica que a gente tem do uso de inteligência artificial. Se a gente for olhar, por exemplo, aplicações de inteligência artificial na saúde, a gente já vai ver o tanto que a gente tem evoluído nesse sentido. Então, como sociedade, a gente tem que se posicionar, né? Se a gente vai querer se destruir ou se a gente vai querer construir um futuro, né, caminhando para o lado da abundância, né, como diz o pessoal da Singularity University, né, o Peter Diamond e tal. Eu até publiquei um texto essa semana, acho que eu mandei no grupo. Eu não acredito num mundo perfeito, num cenário de abundância plena. Eu acredito que o mundo está melhor e vai melhorar ainda mais. A questão que me faz duvidar de uma abundância plena é justamente a questão do ser humano, não é uma questão tecnológica. Porque tecnologia para resolver problema é fácil a gente desenvolver. Difícil é fazer essa tecnologia chegar a todo mundo. De certa forma, as mudanças nos padrões, né, esse efeito de descentralização, empoderamento das pontas, que tem acontecido de forma sistemática nas mais diferentes tecnologias, isso talvez facilite o acesso de pessoas bem intencionadas a recursos capazes de operar essa transformação. Mas, enfim, a gente tem muita coisa pela frente para caminhar nesse sentido. Turupá. Bom, lá no site do iNews tem esse PDF que eu mandei para vocês, tem o link para ele aqui, tá? Se vocês quiserem depois ler, compartilhar com alguém, mandar, né, enfim, ter depois uma fácil fonte de consulta, né? Onde que está o PDF que o Vini mandou no grupo, né? Se não achou, apagou o celular, formatou, lá no iNews tem o link para o artigo original que foi publicado na revista do Prodenge. E o legal é que esse link aqui, ele leva para a revista que não é só o meu artigo. Tem diversos outros artigos sobre inteligência artificial e computação cognitiva lá na revista do Prodenge, tá bom? Bom, a nossa conversa hoje aqui vai ser com o Dr. Roman Yampolsky. Estou colocando esse slide aqui, que é um slide recente. Ele acabou de receber a medalha presidencial por serviços prestados à comunidade nacional e internacional nos Estados Unidos. Então, ele é realmente uma referência no nosso campo de estudo, é uma das principais fontes de pesquisa quando a gente fala de desenvolvimento seguro em inteligência artificial. Destaco aqui duas obras recentes dele, o livro, né, Artificial Superintelligence, e esse reporte, né, sobre o uso malicioso de inteligência artificial, onde ele, junto com mais, talvez uma dúzia de pesquisadores, alguma coisa em torno disso, faz um estudo profundo, é um reporte com mais de 100 páginas sobre como prever, prevenir e mitigar o desenvolvimento maléfico de inteligência artificial. Se vocês entrarem no Google Scholar, vocês também vão encontrar lá mais de 100 publicações onde o Dr. Roman ou participou ou auxiliou, né, no sentido do desenvolvimento seguro. Tá? Depois, se vocês quiserem, me passa ali no grupo só um lembrete, né, que eu compartilho o link desse reporte. Isso é um livro, né, então não dá para compartilhar link do livro, mas o reporte vocês conseguem fazer o download dele na íntegra, de forma gratuita pela internet, tá bom? Bom, então é isso, a pequena apresentação que eu quero fazer. E daí, agora eu já vou cuidar aqui para a gente ficar online com o Dr. Roman Yampolsky, tá joia? Rafa, enquanto eu converso aqui com ele, você quer compartilhar as instruções para a tradução simultânea, por favor?
Pessoal, a gente vai mandar o link pelo WhatsApp. Vai ser um áudio, uma live em áudio pelo Facebook. Então, vocês provavelmente vai ter um delayzinho, mas vocês vão acompanhar bem. Quem trouxe o fone de ouvido do celular vai conseguir ouvir a tradução da palestra. Beleza?
Dá para colocar...
O link, na verdade, já está no evento do Facebook, mas eu vou fazer o seguinte, eu vou entrar e vou compartilhar com vocês, tá? Pelo Facebook para facilitar.
E, de repente, colocar na descrição do vídeo, lá no YouTube, de alguma forma, para o pessoal que está assistindo pela internet também ter acesso à tradução simultânea.
Hello?
Hello? Hello? Dr. Roman? Hello, can you
Hello,
hear me?
can you hear me?
I can hear you now. Can you hear me? Can you hear me now?
Hello?
Hello?
Can you hear me?
Yes, yes.
Yes, yes.
You can? Oh, okay. I always have hard time with Google Hangouts audio. So it's all good?
Yes?
Yes.
Well,
Well,
we are here
we are
with
here
the
with the students and the people that are gladly watching you right now.
Thank you
Thank you very much once again. I have made a brief presentation on Safe AI, just a brief talk, and also presented you to people here. So let me show you. Hey, you guys, that's me. Hello to Dr. Roman.
Hey, people.
Hello.
Okay.
Okay. This talk is also being broadcasted via YouTube. It was better for us instead of Facebook. And now we are ready here to hear from you.
Do you want to point camera at the screen so I can see the slides, or how do you want to do it?
Yes,
we are with the slides here, but if you want to...
It's up to you. I'm just so I know what slide we're on.
Ok. Rafa, ele tá falando que ele pode passar o slide por lá. Prefere que ele passe lá ou a gente transmite aqui? Just a moment, please. Tá. So, it would be better for us if you can transmit the slides from your desktop.
What do you mean transmit from my desktop? Share screen?
Let me see.
I think we agreed that you're going to load them up on your end, and I'll...
It's up on the right, the three dots. You click there and you have the share screen.
Okay, so my concern is I have too many monitors. Let's see how it works. Okay, we'll try this. Beginning. Okay, 1 second here. Share. Okay, is this happening?
Yes, it works.
Okay.
So
feel free.
I'll start and let me know if it's not working. All right, thank you so much for inviting me. It's nice to speak to distant lands. Just a few days ago, I was in Kazakhstan, and now I'm in Brazil. So this talk is a very general introduction to artificial intelligence safety. I make no assumptions about your background. I'll just kind of start from the beginning and tell you what my research is all about and what problems I'm concerned with. In case you want to learn a bit more about me and my work, you can follow me on Twitter, follow me on Facebook. Just, don't follow me home. That's my usual expectation. Okay, so I'm trying to see, did the slide change for you? No. Okay, now it's changing. Excellent. So the first thing I'm going to say is not at all controversial. We already have certain types of artificial intelligence. We know how to make self-driving cars. We know how to make spell checkers, question answering devices, search engines. So in many ways, what we always considered kind of a dream of artificial intelligence, the research we did for many years, is already a possibility. My question becomes, what else we know how to do? Well, not only we know how to make those brains, we also know how to make bodies for them, right? We can make robots, military robots, industrial robots, home assistant robots, all sorts of different bodies, and that's actually somewhat easier problem. We are pretty good at making
humanoid-looking robots at the level which is very impressive. Maybe not as good as a human body, but they're definitely getting very good very quickly. So combining all this together, the question is what will happen next? And one of the predictions a lot of people make is that we're going to get to superintelligence, artificial intelligence beyond human capacity. And the reasons for it are manifold. One is we're getting unprecedented levels of funding for this. So White House, European Union, they're all getting billions of dollars for projects to reverse human brain, to understand how it works and replicate it in software. And also the corporations, Google, Facebook, some of the richest companies in the world, investing again billions of dollars with a B. And they got the smartest people working on it, lots of computational resources. So it'd be really surprising if we didn't succeed at this. It doesn't mean we'll succeed quickly, but it would be very surprising if it never happened. And it doesn't really matter how quickly it happens. Everything else I'm going to talk about still applies, whatever it happens in 20 years, 30 years, 50 years. It doesn't really make a difference to the main points of my presentation. And despite that, people are always very interested to know how soon it's going to happen. I personally don't make predictions. That's not my area of research, but there are other people. Ray Kurzweil is a famous example. People who specifically work on trying to predict exactly what's going to happen and how soon. Kurzweil relies on exponential growth charts and hardware to predict how quickly we're going to get to a certain level of performance, being able to simulate a brain of a bug, ant, mouse, single human, all humans together. And if you listen to him, it's somewhere around 2045, and a lot of people kind of agree with different data that that's the time when we're going to get to human level performance. And very quickly we'll go beyond that, just because you can now combine this performance with all the standard advantages computers have. Access to large data sets, encyclopedias, just very quick processing of data, ability to combine many sensors and so on. So what properties can we expect from those systems? It helps to analyze what they are capable of in order to kind of predict how they might behave and what we need to prepare for. So I go through some predicted capabilities, and obviously for superintelligent systems, being super smart is an obvious property, but what does that mean? So today we're used to computers being super intelligent in specific narrow domains. They are better than us at playing games, chess, checkers, Go, Jeopardy. They are starting to get better at things like driving cars, investing in a stock market, spell checking our essays. But the idea of a super intelligent system is that they would be super capable in all domains at once. Are we good? All domains at the same time. There is also the property of complexity. So we understand the systems have billions of components, and it's really next to impossible for a person to understand how they work. Let's say a deep neural network produces very accurate results, but nobody fully understands just how it arrives at those answers. It's a black box in a way. And likewise, even user interfaces like this control panel for a modern airplane, they are probably a bit too complex for us to fully understand what's going on. And the source code behind the autopilot is so complex, even an experienced pilot probably never had a chance to exercise all this code. And in emergency situations, a lot of times they don't really understand what's happening. And we've already seen examples of airplanes crashing because of this. We frequently talk about keeping control, not surrendering control to machines, but in a way we already give up most of the control software which is not even that intelligent. At this moment, different types of software control stock market, with more than 85% of all trades being done automatically. They control our military response, power plants, electrical grid, air, space control. So essentially, in a way, we already surrendered most of the power, and this happened even before the machines became that intelligent, just software at this point. There is also concern about capabilities which can be used for malevolent purposes, so things like viruses becoming much more intelligent. We've seen viruses become much better at propagating to many more computers as we have more intelligent devices, Internet of Things. They become better and better at infecting all of them, and so the amount of damage increases as well. But what I'm concerned about is capability of combining this with social engineering attacks. We've seen recently Google demonstrate almost perfect communication capabilities. A system can call you on a phone, have a conversation with you. You can't even tell it's not a person. So that is probably the most dangerous way to attack a system, to attack a human behind it, to convince them to give you password in some clever way. And the problem with social engineering attacks is that even trained professionals, cybersecurity experts, they tend to still click on the phishing link. If it looks like it came from your boss, came from your friend, you're very likely to participate. And so this is likely to cause an explosion in malware and viruses. Of course, historically, lots of funding, if not most funding for AI work came from the military. And military has a very specific type of research they're interested in, developing of automated drones, killer soldiers, just weaponized AI. And today, maybe they don't provide as much funding as before, but still it's a significant percentage of overall AI budget. And so we have to be very concerned about this intelligent machines designed to be very effective at hunting and killing people. So it sounds like I have a lot of concerns. I want to make sure you understand that this technology is in many positive ways. It allows us to automate labor, physical and cognitive. We can be much more productive. We can get help with science and medical research, cure diseases, come up with improved theories in physics. And there are some things we can't even predict, the so-called unknown unknowns, where the performance in some domains will be very, very good, very positive for us, but we don't know what it's going to be. So likewise, there is a corresponding negative impact from this technology. It's a dual-use technology, so for every positive, there is a corresponding negative. If we're talking about free labor, economic growth, we have to also talk about technological unemployment, how the machines will take over job market, and how lots of people will have to find different ways of supporting themselves. Likewise, with improvements in robot technology, we'll have more capable machine soldiers. And again, the main concern is this so-called unknown unknown situation, where we anticipate some negative impacts, but we don't really know what they can be. We're not smart enough to predict what they are. So the good news is there is a lot of smart people, very famous people, rich people who are in agreement and are concerned about these developments. And it helps a lot because it creates respect for this level of research and generates necessary funding. And there are now conferences, journals, and books on this topic, which makes it a lot more legitimate. It wasn't the case just 5 years ago. So this is really wonderful. The main concern all of them have is that there is a misalignment between what people want, what we are, and what the machines want. If you look around you, if you look at people on the internet, we all seem very different, very diverse, different religions, languages, different cultural backgrounds. But the reality is that we all almost identical in our blueprint, our DNA, our brain structure. If you look at the tiny blue dot there representing our planet, that's all the human minds, all 8 billion of us or whatever the number is today. Whereas the space of possible intelligent designs is almost an infinite universe. So the probability that by just luck, by chance, we'll end up with a system which is perfectly aligned with human desires, human way of seeing the world, human problem solving is almost zero. So we have to work very hard to achieve this alignment, or we're going to end up somewhere in space where the system has absolutely no concern about our values, human life, animal life, and that, of course, is danger. So I call this problem singularity paradox, the situation where you have this very powerful optimization process with super intelligent machine, but it's too dumb to understand human concerns. It has absolutely no alignment with human common sense, something we all share to a certain degree. So in my research, what I do is I try to understand what type of problems we're likely to see in the future, classify them, predict them, and then hopefully we can address them one by one. So unlike most people, my concerns are somewhat different. So almost everyone in the AI safety field is concerned with problems with implementation of systems. We'll make a mistake in design, we'll make a mistake in programming the system, bug in code, we'll give it maybe bad goals, misaligned goals from what we intended, maybe the environment will some sort of a problem, short circuit or cosmic rays or something like that. Whereas I'm more concerned about the same problem as what I talked about with viruses, where it's a malevolent design and purpose. Somebody, for whatever reason, it's terrorists, criminals, crazies, whoever it is, wants to make a system to cause damage on purpose. And so, to me, this is strictly worse, not just because you getting a malevolent payload, you're also repeating all the other possible problems, right? When you're designing your virus, you can still make a mistake in coding it, make a mistake in how it terminates. So it seems that this is a strictly bigger problem, and very little research goes into specifically addressing malevolent AI, right? So there is, I think, 1 or 2 papers published so far on this, and I think both of them originate with my research group. Again, the good news is there is more and more people now are concerned with this problem. There's a lot of books published on different aspects of what we may expect, how we can work to overcome it. Probably Nick Bostrom's book, Superintelligence, is the more famous one, but there is books from different authors, and it's very refreshing to see this happen. Likewise, there is now explosion of different organizations which are all kind of devoted to working on this problem. So all the top universities, whatever it's Cambridge, Oxford, MIT, Berkeley, my university, they all now have labs specifically dedicated to working on AI safety. And this is very good. There's a lot of publications, a lot of progress in this field. So this is a pretty good update on what's happening in recent years. When we just started this some years ago, there was nothing like that. There was no support, no organization. So the first thing we had to do was kind of establish the field to look at what has been done, what concerns people had. So one of the first things we did, we surveyed all the literature we could find, some 300 references, all published on this topic of how can we address control of intelligent machines. And this survey is available for free. You can download it. It's an excellent introduction to the field. I think at this point it's been downloaded like 16,000 times or something, very large for such a niche subfield of research. And in it, we tried to classify how different people propose working with this. And obviously, I don't have time to tell you about all 300 solutions, but I'll kind of give you introduction of the ideas people had about what we can do, and maybe we can talk about in Q&A session about why they work or don't work in your opinion. So the first solution people propose is really this do-nothing approach, right? So I don't even have a picture for it. It means nothing. they say that we don't have to worry about it. Nothing's going to happen. We're not going to succeed at creating intelligent machines. So if we succeed, they're not going to be mean to us. They'll be nice because we're smart. So again, you don't have to do anything. The problem with this approach, it's very hard to get research funding for something like that, right? So that's an issue for me. But also, it seems like they're ignoring the problem. Others, like the famous Unabomber, said that the problem is so important we cannot afford to get to the point where we have intelligent machines, so we have to give up technology, and in the process give up all the benefits from technology. And he was so into it, he was willing to kill computer scientists just to stop progress in artificial intelligence. As a computer scientist, again, I'm strongly against this approach. There are some proposals for trying to integrate machines into society using legal framework, using economic framework, but it's not obvious how something which is essentially immortal, cannot be punished, doesn't have interest, can be rewarded or punished using the same means as human beings. So like, how do you punish a computer? It doesn't seem obvious. They have backups, they can hide data and so on. So the other proposal is to say, okay, we can't compete with them directly. What if we enhance ourselves, become smarter, modify ourselves so we become more competitive? And those are the options where you can either try and upload it to a computer, create a computer simulation of your brain, which you can now run faster, and maybe it will be smarter as a result, consider more options. Or you can have some sort of an integrated system, neural lace they call it, where you have computer integrated with human brain, and the hybrid system is more competitive than either one alone. So again, this seems like a good idea, and it might work in terms of technology, but it's not obvious that in a process we don't lose humanity as well. If we become software on a computer, just simulations running in that space, how are we different from the intelligent software we're trying to compete with? Probably the most famous solution is this 3 Laws of Robotics by Isaac Asimov. I'm sure all heard of them, read books, saw movies. The problem is that they are literary tools. They are not meant to be actual solutions to any problem, so they are designed to fail. They are self-contradictory, they're ill-defined, and if you read the books, you know they always lead to problems. They never actually solve anything. So if you remember one thing from this talk, remember this is not a solution. Even if you increase the number of rules, make it 4, make it 10, it doesn't matter. It still creates the same exact problems. So what was it we're trying to do in my research group? One project we're working on is formal verification, where we try to develop mathematical proofs, mathematical tools to show that software we create is actually working as expected. And there is a lot of good tools in computer science and mathematics for software verification, but the problem is no one knows how to apply it to intelligent software, which is independent, which is self-changing, learning, and works in open domains. We're pretty good at verifying things in a closed domain with only a few options possible, whereas in this open domain situation, it's still an open problem if it's possible at all to do this type of verification. The other project we're working on is containment tools. If you're working with a computer virus, a lot of times the standard protocol is to isolate it from the internet, be able to study it, study what inputs, what outputs go into that system, how can we figure out what it does, what it's learning, and limit its access to the person. So in case of AI, this is to prevent social engineering attacks, prevent it from escaping to the internet. And what we proposed is a protocol with multiple layers where we can control inputs going into the system, outputs coming out of the system, and we can decide just how much information the system gets, what it can learn, and so on. So this is an ongoing project. We got funding for it initially. We're still applying for additional funding to complete this. If we get it, we plan on creating a whole virtual environment in which different AI research groups can test their systems. We don't think this is perfectly secure. We think at the end, the AI always escapes from containment protocol, but I think it's a useful tool to buy us more time to do this research, to study what's going on, and to develop safer intelligent systems. So overall, in science, we don't like being told what to do or not to do, but we all kind of agree that certain types of research are unethical. Experimenting on babies and animals, chemical weapons, nuclear weapons, we all kind of agree that maybe we shouldn't be doing those things, right? And the typical solution, especially in medical research, is to have a review board which looks at the proposed research and either approves or doesn't approve this work. So you can see how this is very standard in university settings, not as much in industry settings, but it's never been considered as a useful tool for software, to develop software. But a few years ago, we actually proposed this idea. We should have review boards for web projects. And at the time, it seemed kind of crazy, but since then, a lot of big companies, important companies, for example, Google's DeepMind, have adopted this idea. And now multiple companies actually have research review boards for AI. So the main job of such a review board is, in my opinion, to separate projects which are completely harmless, very narrow AI projects. You're doing something with no capability of learning, no ability to self-modify, something like a spell checker or text software, from projects which actually are universal, general, can learn and can potentially become as intelligent as people. And that's the full-blown artificial general intelligence. And that's something where we need to go, well, if you think your project is capable of doing that, what safety mechanisms do you have in place? What control options do you introduce? Can this be something very dangerous, and maybe we shouldn't be doing it? So that's kind of the state of the art in that. So I'll conclude by making a few predictions. One of the things I do is I collect examples of how AI systems fail. This is a small snippet of it. The full paper has examples from 2017, 2018 now. You can find it. But it seems like every time we design an AI system, eventually it fails to deliver exactly what it is we are designing it to do. So we can project this forward and see that, first of all, as we have more computers and more intelligent systems, more of them will fail. And as they have more responsibility, the impact from them failing will also increase exponentially. So between systems failing and malevolent design on purpose, the prediction is that we'll see more and more problems, and they will increase in damage, in how they fail, proportionate to capabilities of those systems. So we really need to, especially in commercial settings, when we're releasing an intelligent product, be aware of it and prepare for AI system to fail in exactly ways we anticipate. So a famous example is this Microsoft Twitter bot, which was released with capability to learn from its users, and immediately became very vicious, racist, sexist. So the question is, why wasn't this obvious? Why didn't the designers predict this outcome? And I think with the research we now published, with available information, there is no excuse for repeating this type of mistake. So I think as long as we prepare for this, we are ready and we know what to anticipate, we can actually be much, much better off, much safer. I'll leave you with some references. If you're interested, you can get all these papers behind it. They're available on my site, completely free of charge. Check them out. We had a book come out a couple of years ago, kind of introducing some of those ideas. I have a new book coming out in August with all the top AI safety researchers. This will be available very soon if you're interested. And I think we agreed I'll answer questions from the audience. So if you have any questions, I'll be very happy to address those.
Hello.
Hello.
Nice. Well, thank you very much once again. We have some questions here, and I will start with some here, and people can make questions too. Se vocês quiserem fazer perguntas, podem fazer em português. Se for o caso, ou cadastra lá no slide, mas quem está aqui pode falar aqui diretamente, tá? Well, Dr. Roman, we can see we can see in the media recently.
Let me stop sharing this and I'll go to
Okay. Thank you.
We
You can see a lot of media talking about problems and accidents with artificial intelligence, and you have showed us a list of some examples. And we can see many times that errors come from human errors, not software or hardware or computing errors, as you said in your presentation. And sometimes about, for example, the Cambridge Analytica effect in Facebook. We may think that people sometimes act in a naive way. They don't mind what that could lead to. At least it was what Facebook said. So when we are talking about developing artificial intelligence systems, what kind of practical action or technical procedure should we attempt to in order to develop safe AI? I mean, how not to be naive.
Right. So it's important to keep safety in mind. You have to change the way you approach projects from I just want to get it done and sell it as quickly as possible, beat my competition, to considering, well, how will that impact my company, my customers, how will it impact everything in 5 to 10 years? We have a very bad record of doing it. Then we developed initial internet. There was no concern for security, and now we're all paying the price for it. We're now developing Internet 2.0, Internet of Things. Again, almost no security goes into it. Every day we hear about cameras hacked, all sorts of devices have default passwords. There is no security by design. And it's important that we don't repeat this with intelligent systems. So you need to have someone on your team who's an expert in it, who thinks about it. The first question you have to ask, how can this system be misused? How can it fail? So I'm releasing this tool, this product. Well, like any other tool, it can be used for good or for bad. If you have a hammer, you can build a house or you can kill someone with it. How can a company predict all the negative uses of technology and at least try to mitigate it, limit it in some way? I don't hear you.
Okay. Can you hear me?
Yes.
Okay. When we talk about regulation as a necessary tool for safe AI, some people say that regulation may act as a monopoly tool. So just the big companies, just the guys with money, and the ones that already have the technology could continue researching or have some results. In the other hand, we have, for example, that work in an open source way that are asking for, no, you cannot regulate, you cannot forbid anything, because it's better to have everybody researching, because we will have more people that know the technology and will be able to deal with errors, accidents, if they happen. How can we balance this two hands approach of regulation and openness?
That's a very good question and a very hard one. I don't think there is a definite answer, and we're still kind of looking at it. So you are right. If we make it open source, now all the crazies, all the terrorists have access to this dangerous information. They have the tool they can use to attack systems to cause damage. On the other hand, if government steps in and closes it and regulates it, that creates additional problems. Usually regulation doesn't solve anything, whether it's drugs or prostitution or whatever. Government has a very bad record of actually successfully regulating anything. So the question kind of goes to how hard the problem is. How difficult is it to make AI? If it's easy, if you can do it at home on your laptop, then regulation wouldn't make a difference. You would still do it at home. If it's very difficult, like Manhattan Project, like building a nuclear bomb, you need billions of dollars, you need factories, you need resources, then regulation can help a little bit to limit what happens. Big companies, Google, Facebook, can be controlled in some way. But we still don't know how difficult it is.
Good. When we talk about formal verification, I have a doubt because I was watching for Stephen Wolfman presentation on MIT, and that was a situation where I could see his system working, and he showed the outputs of the neural network working in order to have an answer for a question. And the example was concerning computer vision application. He submitted a picture, and the neural network was working on identifying what was on the picture. And as a human, I could not understand anything that was going on with the neural network. So for me, it's very difficult to understand how could we implement verification on neural network, as we are not able to understand the outputs of the neural. What do you think about it?
You're right, we can't, and it's a problem, but it's not a new problem. It's the same with people, right? With other people, you don't really understand how they make decisions. You don't really have a way to verify that they're safe. There is no safe human. So essentially, it's the same problem, just amplified to this new technology. And the best we can hope for is that, okay, we tested it in different situations. It seems to be safe. It didn't kill us so far. But it's unlikely that there is a mathematical proof for something like that, just because it keeps changing. It keeps learning. It keeps updating its weights. So it's never the same exact problem as you started with.
Okay. Perguntas? Okay. Let me see if we have questions from the internet. No? Tem alguma pergunta por aí? Não? So I'm going to ask one more question. Okay, I'm liking it a lot. For me, it's pretty cool. We talk about narrow AI, we talk about general AI, artificial general AI, and sometimes we hear about singularity. For you, what is the relationship between AGI and singularity?
Right, so AGI is human-level intelligence. We get to the point where we are as good as a human. Very quickly, it becomes super intelligent. It goes beyond us because it has more memory, it's faster, it can accumulate knowledge, read every book. So that leads to super intelligence, which is now capable of modifying the world, inventing new things at a pace we cannot keep up with. So like if you're used to having a new iPhone come out every 2 years, now it's coming out every year, every month, every minute, every second. You can't keep up. You don't know what's going on anymore. That's the singularity point where you can't make predictions beyond that. So they all kind of come almost at the same time. Once you get to human level intelligence, you can expect the other two very quickly.
Good. Well, I did finish my questions. Let me see. Ninguém? Nobody? Sim? Just a moment, Roman, please.
Yes.
Roman.
Yeah.
A technical question concerning algorithms. We now have many new techniques for implementing artificial intelligence, as regression, clustering, classifying, neural networks, and so on. What do you think is the most preeminent, or the one technology or algorithm or model that's going to be much used in the following years?
So it looks like deep neural networks are making very good progress, and since they are based on human model and we know human brain works, it's very likely that it will continue to improve as we get more hardware and we get to the point again in 2045 or something where we can match performance of human brain. It's likely that that's the model we're going to use to get to superintelligence.
Good. Okay. Do you have labs on the Louisville University for development on AI?
So I teach artificial intelligence course, and we work on multiple projects on different aspects of it. It's a very conservative, very traditional engineering course in AI. We study search algorithms and things like that. So yeah, not as much work on AI safety for most students. That's more of a research project for my PhD students, master students.
Okay. And which language do you use to try AI?
Yeah, I'm not very restrictive. Anything my students are comfortable with, I let them use. I don't force them to use a specific language. A lot of times they use existing toolboxes out of MATLAB or something like that for evolutionary computing, for neural networks, but they're free to use whatever they want.
Okay. Well, I think that's it. Mais perguntas? Não?